So we saw when we did our exercise in the previous section that the one and only physical connection to our Bitcoin is this large and random number. This is our private key. So this lecture covers why large random numbers are so powerful. And starting with the foundational definition, this was given to us by Donald Knuth over 50 years ago. So the definition, one, each of these digits is its own unique value, an independent random value. And any digit, say this one for example, this value has no other relationship to any of these other values. And then lastly, each of these values is independent. Each independent value has a 50-50 chance of being either a 0 or a 1. But an easier way to see this definition is through a coin flip. So imagine we flip this coin 4 times, and each time, of course, it's going to land on either tails or it'll land on heads. And this is how you can visualize the randomness of flipping a coin over and over again. This is called a binomial random walk, and one of these pathways has to happen. So I'm going to pull down an example, and we're going to say that this pathway happened. We landed on tails, and then heads, and then tails, and then heads again. And now we're going to define this pathway, or we define all these pathways by their ending point. This shows the path it took. 0 represents tails, and 1 means heads. So in our example here, we have 0, 1, 0, 1. And this is now a small example of our definition. So each of these values was the result of pure chance. Each coin flip is independent of all other coin flips. And every time you flip a coin, it's a 50-50 chance, an equal chance of heads or tails. So the basic math behind this, if we do 4 coin flips, there are 16 potential pathways. And because there is no pattern in a coin flip, all of these have an equal chance of happening. Now, if we do 5 coin flips, we have doubled the number of pathways. And this doubling just continues, and then you reach points quickly where these numbers are ridiculously large. So now we have 2 things. We have a process with no pattern. It is completely unpredictable. And if we do it a certain number of times, we get incredibly large numbers of possible outcomes. So for an example, we flipped a coin 256 times in a row. This is a random output of doing that. Now we had this random number, and we're going to put this number through a process. And we'll see public keys more in a couple of sections. But for now, just know that this process requires electricity and time to go through, albeit in very small amounts. But if you can create a guess and check situation where an adversary has the only option to guess and check, so they're just going to start at the very bottom, they're going to run this number through this process and then check the result. And if that's not the result they're looking for, then they go back, do one iteration by changing this single bit, and then they repeat the process and continue to do that. So in the land of cryptography, we just pick a number that is insanely huge. This is the random binary number, 2 to the 256. And while it is technically possible to do this many iterations, this is the amount of time that it would take to cycle through all the guesses and checks. And this is if you had all the compute power in the world. So it is safe to think of this as absolutely impossible to do this. So random numbers, large random numbers, make it impossible to reverse or hack or break cryptographic protocols. And the term is called computationally infeasible. So random numbers are also not predictable. So you cannot predict a coin flip. It's the same with rolling dice and gambling games, anything not predictable. And there's actually a store in California where you can buy random numbers that are translated from lava lamps because it is not possible to predict how the lava is going to flow around. And as an example of what not to do, so software programs like Excel have these functions built in that are called random, and it may appear you have a random number, but these are not random numbers. These are actually the result of a behind the scenes algorithm, and this is just an example picture of an algorithm. But what that means is there are relationships between these numbers, so they are not random. But a number that is random is very powerful.